Today's notes are from section 6.2, which is titled Systems of Equations by Substitution. So there are three ways to solve systems of equations. We learned the first of those three ways last class. That was by graphing. Graph the two lines, see where they cross. Today we are learning how to solve them by substituting. So example 1 asks us to solve y equals 3x minus 4 and 4x minus 2y equals negative 2. Y equals 3x minus 4, 4x minus 2y equals negative 2. And we are asked to solve this system by substitution. The word substitute means to take something and replace it with something else. So when we replace something, the two things need to be equal to each other. So notice here we have an equation. It says y is equal to 3x minus 4. So I know y and 3x minus 4 are exactly the same thing. They're equal to each other. So I can rewrite this second equation right here, this one, as 4x minus 2, but instead of y, I am substituting in what y is equal to. So it says 4x minus 2y equals negative 2, but instead of y, I am putting in what y is equal to, which is 3x minus 4. I replaced the y, I substituted the y with what it's equal to. And we have solved lots of equations that look like this. I've got a number in front of a parenthesis. We start by distributing. So I've got this 4x out front. I'm doing negative 2 times 3x and negative 2 times negative 4. Four x minus 6x. I'm combining these like terms right here. 4x minus 6x is negative 2x. Subtract 8 from both sides. Divide both sides by negative 2. I get x equals 5. Remember, a system of equations, we not only need an x value, but we need a y value as well. I know my x value is 5. You can go to either equation and plug 5 in for your x. You could plug 5 in here. I think the easiest place to plug in 5 would be right here. I get y equals 3 times x minus 4, but I know x is equal to 5. 3 times 5 is 15. 15 minus 4 gives me 11. X equals 5, y equals 11. You can write it like this, x equals 5, y equals 11, and circle it, or you can write it as an ordered pair, which is how we were doing it last class. Either of those are acceptable. Number 2, let's try another one. Similar problem. Instead of x's and y's, we've got a's and b's in there. It says 4a minus 2b is equal to 24, and a equals 3b plus 11. 4a minus 2b equals 24, a equals 3b plus 11. This time in the problem, it says a equals something. So I know what a is equal to. So I'm going to go to this equation, and instead of a, I'm going to replace a with what it's equal to. I'm going to take 3b plus 11, and I'm going to put it in for the a. So anytime I substitute, we're going to use parentheses. 4 times a, but instead of a, I'm putting in 3b plus 11. minus 2b equals 24. I rewrote this equation at the top exactly the same way, but instead of a, I put in 3b plus 11 for the a. From here, we distribute 4 times 3b, 4 times 11. That's the end of the parentheses, so I'm done distributing. I'm just copying everything else down. We are going to combine these like terms. 12b minus 2b. 12 minus 2, I've got a total of 10 b's. Subtract 44 from both sides. (24 minus 44), that's negative 20. And divide both sides by 10. I get b equals negative 2. Again, I found b, that's great, that's part of my answer, but I need both variables. In this case, I also need a. I can get a by plugging negative 2 in for my b. I get a equals negative 6 plus 11. A equals 5. A is 5. B is negative 2. Number 3. Number 3 looks pretty similar. 2y minus 7 equals x. 3x minus 6y equals 11. 2y minus 7 is equal to x. And 3x minus 6y is equal to 11. Let's start by substituting. We always need to find an equation that says a equals or b equals or x equals or y equals. In this case, it says x equals 2y minus 7. So I know x is the same thing as 2y minus 7. So instead of x, I'm going to put in 2y minus 7. Those two things are equal to each other. It says it right here in this first equation. So I've got 3 times x minus 6y equals 11. But instead of this x, I'm putting in what x is equal to. We can distribute our 3. 3 times 2y. 3 times negative 7. Combine up your like terms. 6y minus 6y, I don't have any y's. I just have negative 21 equals 11. Remember when we solved by graphing, sometimes we wound up with lines that were parallel with each other and they never crossed, and we said there was no solution. So systems of equations sometimes have no solution. In this case, negative 21 is not equal to 11. When we get down to something that makes no sense like that, I don't have any variables left. I have a false statement, a statement that is never true. That is when we have no solution. Remember also, sometimes our two lines lined up right on top of each other, which mine don't, but suppose they did. In that case, we had infinitely many solutions. If we solve by substituting and we get 11 equals 11, that's when you have infinitely many solutions. If the two numbers are equal to each other and all the variables canceled out. We've got a couple more we're going to look at. Number 11. D equals 4c minus 2. And 6c minus 4d equals negative 2. D equals 4c minus 2. 6c minus 4d equals negative 2. We are solving by substitution, so the first thing we are going to do is take d, which is equal to 4c minus 2, and we're putting it in for the d. So 6c minus 4, instead of d, we are putting in what d is equal to. 4c minus 2 in for the variable d. Now we distribute. I've got this 6c instead of negative 4 times the quantity. We're going to distribute this negative 4. Negative 4 times 4c is negative 16c. Negative 4 times negative 2 is positive 8. 6c minus 16c, those are like terms. That's negative 10c. Subtract 8 from both sides. Negative 2 minus 8, that's negative 10. And divide both sides by negative 10. Negative 10 divided by negative 10 is 1. Way too often I see students, they do all this and they do a great job and they get c equals 1, they circle it and then they stop. Don't forget, I not only need c, I need to figure out what d is equal to as well. We can do that by plugging c equals 1 into either equation. The equation that says d equals is going to be the easiest place to plug it in. D equals 4 times c, which is 1, minus 1. I'm sorry, minus 2. 4 times 1 is 4, minus 2. And now we have both variables. Last one, again, I want you to pause the video. You try this one, see how you can do once everybody has it. Restart the video and see if you're correct. Y equals 1/2 x minus 4. So 1/2 x minus 4 goes in for my y. So 3x minus 2 times y equals 14. But instead of y, we are putting in 1/2 x minus 4. We distribute. Negative 2 times 1/2, that's negative 1x. Negative times negative is positive 8. 3x minus 1x, that's 2x. Subtract 8 from both sides. I get 2x is 6 and divide by 2. X is 3. Plugging 3 in for my x, I get y equals 1/2 times 3 minus 4. 1/2 times 3. When we multiply fractions, we multiply straight across. 1 times 3 is 3. 2 times 1 is 2. And this is good review here. Subtracting fractions. We need a common denominator. Can make the denominators both 2. I multiplied 1 by 2, so multiply 4 by 2. And then to subtract fractions, we just subtract across the top. 3 minus 8 is negative 5, and keep the denominator the same. Y equals negative 5 over 2.